Okay, homework Q5, the radians homework, and I've got the diagram here from the sheet and annotated it slightly 3 centimeter radius, and I've put theta there for the angle that we're trying to find first of all. So that's the angle we're trying to find first of all. We've got 3 sides of the triangle, so that's a cosine rule problem. 3 sides, 1 angle is a cosine rule problem for part A, and so you may or may not be familiar with this particular version of the cosine rule, where you let cos A be the subject. So b squared plus c squared and minus a squared over 2bc. If you're more familiar with a squared equals b squared plus c squared minus 2bc cos A, that's absolutely fine. You can substitute the numbers straight into there and then rearrange later, or you can rearrange that first and you'll get to here. That's completely up to you. Okay, but I'm going to, since I know it, let's use this version. Okay, so cos A, well, that's theta here that we're trying to find, of course. B squared, my B, opposite the B there is the 5, opposite the C there, sorry, opposite angle C is little c there, so that's 9, and opposite angle A there is little a, so that's 10. Okay, and B is 5 again, and C is 9 again. So there we go. All we now need to do is churn that through and then inverse cos it. So inverse cos of the result of that. Okay, so 5 squared plus 9 squared, oops, minus 10 squared, all over 2 times 5 times 9, and that's 1/15. Okay, inverse cos of that in degrees. Are we okay in degrees? No, of course we're not, we're in radians. So let me then make sure I change my settings to radians. So set up there, angle input is option 2 for radians, and I've now got a little r in the top. Okay, now I can do inverse cos of 1/15. And there we go, 1.504 to 3 sig fig, to 3 decimal places rather, as required by the question. A little c there for radians. Okay. Right, part B. Find the area of the sector APQ. So this area A to P to Q here. That's supposed to be a Q, clearly, according to the question. That's not very clear, is it? That's supposed to be a Q. A to P to Q, sector there. That's what we're aiming for. Now for this we need to remember the new radians formula. So sector area equals a half r squared theta, so long as theta is in radians. Okay, so that's the formula we're going to use. And we've got theta in radians anyway, so we're okay to roll with that. Okay, so area then is going to equal a half times the radius, and in this case, of course, the radius of that sector is 3. And theta then is 1.504. Although if you've still got the full calculator value from earlier, then use that in your later calculations, and I do still have that calculation in my screen, look, so I can now just multiply that then by the 0.5 and by the 3 squared, and there we go, 6.768 etc. Oops, 6.768 etc. Doesn't tell me what to round it to, so I'm just going to round it to 3 sig fig after that, so 6.77 to 3 sig fig, and that will be in centimeters squared. Okay, right, part C, and we're on to the area of the shaded region this time. So the shaded region there is clearly the full triangle, take away the sector area that we've just calculated. Okay, so the first thing we're going to need to do then is work out the area of the full triangle. And area of the triangle, there's a formula to make sure you know, half AB sine C, although that's with C as the angle, but of course we don't have C as the angle, we've got A as the angle. Okay, so therefore with A as the angle, I'm going to slightly rewrite that here, half BC sine A. Okay, so that's the version we're going to use. I'm just going to put that one in bold though there for you, because that's a formula that you need to learn. That's usually the version of it that people learn, half AB sine C, and then you've just got to be a bit savvy to, depending on which angle you're using, of course, depends on exactly which letters you use and where they are. Okay, so for us though, it's half BC sine A. Okay, length B then is 5, length C is 9, and our angle is 1.504 radians. Strictly speaking, obviously, if you had it full calculator value, that would be helpful. Now, it was inverse cos of 1/15. Oops. That's how I got my 1.504, so I've got it back again there. And of course, don't forget you can store these key numbers sometimes if you press store there, STO, and then straight for the letter you want. So if I'm going to store it as letter A, there's a pink letter A there just above the negative sign, and you can see the answer has gone into option A. So then if I then press alpha A equals, it brings that number back up again. So a really nice way of storing values for future use. Okay, I've got my value then. What am I doing with it? I'm taking the sine of it, and then I'm multiplying it by 0.5 and 5 and 9, and I get 22.4499, etc. Okay, so that's the area of the triangle. Let's put that there, triangle area. Okay, so crucially then, shaded area is the triangle area, take away the sector area. Okay, and for us then that's 22.449, etc. Subtract the 6.768, etc. And I should have stored that in my memory too, shouldn't I? So, what I'm going to do then is store this triangle area as B. Okay, so that answer's gone into B. And my sector area was gained by doing 0.5 times 3 squared times, what is the angle, which is put in angle A. There we go, that's the full calculated value for my sector area, which I can now subtract from the triangle area, because I had saved that as option B. So I'm going to do option B then, take away the answer, and there we go, 15.68 dot dot dot, 15.723 fig. Okay, and finally, find the perimeter of the shaded region. Okay, so let's mark on here what we've got then. So full length there was 9, that bit of radius was 3, so clearly here we've got 6 centimeters there. We know the bottom's 10, and then the full length there was 5, that bit's 3, so this is clearly 2. Crucially, what we need is the arc length there. Okay, so it's the final formula then that we're going to be using in this question here. Another formula for you to make sure you know. Arc length L equals r theta, theta in radians. Okay, so in this case then, the radius is 3 and theta, the angle, I'd stored in my calculator, which is useful. It was 1.504 dot dot dot, but I've stored it in my calculator as option letter A. So 3 times alpha A like that, and I get 4.5122, etc. Okay, which I'm going to keep in there for the minute because I'm going to use it now to then say, okay, so therefore the perimeter of the shaded region is equal to that 4.5122, etc., plus the 6, the 10, and the 2. Okay, so I've got that on my screen anyway, the 4.5122 plus 6 plus 10 plus 2, 22.5122, etc., 22.5 centimeters to 3 sig fig. There we go. And that is the end of that question.